Hello, and welcome to the training series for the Su-25T Frogfoot. In this video lesson, you will learn takeoff procedure, basic trimming, and maneuvering. This lesson covers a lot of material, and I strongly recommend you go and find some additional information on the principles of flight and flight mechanics immediately after finishing this video. I assume you have already completed part 1 of this series, and that you know how to start up your aircraft, change your payload, and taxi to and hold short of the proper runway for takeoff. If you haven't completed part 1, or if any of those topics sound unfamiliar to you, you can find a link to the previous lesson in the video description below. We will pick up right where the previous mission left us, holding short of runway 26 at Kutaisi Airport, after being given taxi clearance and slowly taxiing to this point. Our position lights are turned on and blinking, showing our location to any nearby aircraft and indicating that we plan to be an actively moving ground object. Our taxi lights are turned on as well to illuminate the taxiway in front of us. Furthermore, we've had all the weapons removed from the aircraft to lighten it up and make it easier to control. Let's go ahead and request permission for takeoff and position ourselves on the runway. Press the # key on your keyboard to bring up your radio menu, and then we can see that we need to press F1 to request takeoff. The tower will clear you a few seconds later, assuming no one is currently on the runway. They will also tell you how fast to climb and what barometric pressure your altimeter should be set to so that it reads 0 for this airport while you're on the ground.
Kutaisi, Springfield 1-1, request takeoff. Springfield 1-1, Kutaisi, you are cleared for takeoff when ready. Climb 300 at QFE 756.13.
To be honest, in the scope of this simulation, neither the climb number nor the QFE is very important during takeoff. The QFE is mostly relevant during landing. If you did want to set the QFE for realism's sake, take a look at your altimeter. And that's this gauge right here. The numbers around the circumference of this dial indicate tens of meters of altitude, and each full revolution of the needle indicates 100 meters. As you can see, the needle is currently pointing just shy of 5 meters altitude. We're still on the ground, so it should read 0. You'll notice that the topmost rotary display is also just in between, indicating 4 and 5 meters of altitude. As you may have guessed, this rotary will also give you a more immediate indication of how many meters you are in the air. An important bit of information to note is that these numbers both represent your aircraft's barometric altitude. This is your altitude based on the outside air pressure, or barometric reading. By default, the altimeters are set to the barometric pressure of sea level. So even though you're on the ground here at Kutaisi, the airport itself is just about 5 meters higher than sea level, as indicated on this instrument. This is why airports provide you with a QFE number. You can use the barometric pressure of the airport to adjust your altimeter so that you have a better idea of how close to the ground you actually are. It comes in handy during low visibility conditions and in the case that your aircraft's HUD is damaged or inoperable and unable to show you your radar altitude. We'll get to the radar altitude, or the height above the ground that you're currently traveling over as measured by the plane's radar sensors, later in this lesson. The QFE in the Su-25T is indicated by the rotary display at the bottom of the altimeter. To adjust your barometric pressure on the Su-25T altimeter to match the QFE provided by the tower, you can hold right shift and tap the minus key to lower the number, or right shift and tap the plus key to raise the number in this display. While you're on the ground, you can also just adjust the QFE until the altimeter reads 0. If you return to the same airport after your mission, the QFE will not have changed. If, however, you end up landing at a different airport from the one you started at, the QFE provided by the destination airport will likely not be the same as the airport you departed from. We will be departing and arriving at Kutaisi during the course of these training lessons, so once you are satisfied with how your altimeter is set, taxi out to the middle of the runway, turn to the right to line up with the center line of the runway, and come to a complete stop. We are almost ready for takeoff. Before we actually do start down the runway, I would like to go over a few more important gauges that you should be aware of. As we mentioned before, your HUD, which is your heads-up display, gives you a reading of your current radar altitude, indicated by the number in the top right. It's difficult to see while we're on the ground, but at the moment it shows a 0 and it's overlaid with an R. This overlay problem is a small bug that only occurs while you're on the ground, and it should be fixed in a future release of DCS World. This number will increase as you gain altitude, and decrease as you lose altitude. The letter R will remain on the HUD until a certain altitude, somewhere around 1400 meters, indicating that the HUD is displaying your radar altitude. Once you ascend above approximately 1400 meters, the R will disappear, indicating that the HUD is now displaying your barometric altitude. Descend below 1400 meters, and the HUD will begin to show you your radar altitude again. In between the altitude and speed displays of your HUD, you'll notice this horizontal heading tape. It's a quick way to tell which direction your aircraft is currently traveling. The small triangle beneath the solid horizontal line represents the nose of your aircraft, and as you turn, the heading tape will also slide side to side to show you your new course. Each vertical numbered tick mark along this tape represents 10 degrees of rotational direction, with the unnumbered tick marks representing 5 degrees. As you've probably guessed, these numbers are truncated versions of the full heading. Multiply the numbers you see by 10 to get your actual heading. Currently we're pointing at about 255 degrees. 254, 255 degrees. The multitude of lines at the center of your HUD are a virtual representation of your aircraft with relation to the horizon. The 3 lines at the very center, this one vertical line and the 2 horizontal lines that almost look like police batons, indicate your aircraft's tail and its 2 wings, while the long solid line just beneath it represents the horizon itself. As you bank the plane from left to right, the solid line will remain parallel to the horizon, while the aircraft representation will bank and roll with the plane from side to side. The semicircle of tick marks beneath the virtual plane indication indicate common bank angles in degrees: 0 degrees, 5 degrees, 10 degrees, 15 degrees, 30 degrees, and 60 degrees. The number to the right of your virtual plane indicates the angle relative to the horizon that the fuselage of the plane is traveling in. Currently, level on the ground, the plane's nose is pointing up about 4 degrees. That's just the way that the plane is oriented, and if you go to an external view and take a look at it, you'll notice that it's not completely level. The plane does actually point upwards, just very slightly, and that is indicated on that particular part of the heads-up display. The number to the right of that is your climb or descent rate. It will be positive if you're climbing, it'll be negative if you're descending, and that horizontal arrow to the right of that vertical bar will move up or down depending on whether you're climbing or descending. The other important gauge for takeoff is this set of indicator lights right here. You'll notice the drawn representation of your aircraft with several lights below and a couple of lights above. The 3 lights that are currently lit up represent your landing gear. Currently, our gear is down, so these lights are lit up green to indicate that. After we take off and retract our gear, the lights will turn off to indicate each wheel has completely pulled up into the fuselage. The 2 vertical lights above each wing represent your air speed brakes. These are useful to have if you need to quickly slow down the aircraft while you're in flight. For example, if you're coming into land and going too fast, or if you're on a dive attack on a target and you don't want to overspeed the aircraft. If you overspeed the aircraft in a dive and pull up too sharply, you run the risk of snapping the wings off. You can press B to extend and hold Control and tap B to retract them. You'll notice the lights for the speed brakes come on when the brakes are extended and turn off when they are retracted again. Externally, your speed brakes look like this. The remaining 4 horizontal lights, 2 under each wing, represent your aircraft's flaps. You'll notice you have two stages of flaps. Stage 1, the maneuvering flaps, are useful for takeoff when you're heavy or using a short runway, and for any low-speed aerial maneuvering you might need to do, such as preparing for landing or lining up on a ground target. Stage 2, fully extended flaps, should only be used for landing the aircraft. You can extend Stage 1 flaps by pressing F, and extend Stage 2 flaps by holding Shift and tapping F. You can retract the flaps fully by holding Control and tapping F. And externally that looks like this. These are your maneuvering flaps. You'll notice they don't extend too much. And here are your landing flaps settings. You'll notice that the flaps drop significantly further, and that increases the drag on the plane quite a bit, so you have more of a chance of stalling with the landing flaps extended. I'll go ahead and retract them fully. We have no weapons and are on a decently long runway, so we're going to take off without our flaps extended at all. They're going to be fully retracted for takeoff. Go ahead and center your view, reset your zoom in preparation for takeoff. In many instances, I like to actually zoom out just a little bit so that I can see more of my instruments. This is personal preference. You can zoom out using the / key on your number pad. Now that we're on the runway and ready for takeoff, what we want to do is extend our takeoff lights. It's the same key as your landing taxiway lights. It just is a different setting. It pushes the lights further down the runway, makes it a little bit easier to see as you're taking off and landing what's on the runway. Not so useful during the day, but it's good practice to get into for nighttime landings or dusk landings where visibility might be an issue. Go ahead and hold down your wheel brakes and smoothly increase your throttle to 80% RPM. Then release your wheel brakes and continue smoothly raising your RPM to 100%. The aircraft will start rolling down the runway.
Clear to taxi to runway 26.
Use your rudder controls to stay lined up with the center line. Once your speed reaches approximately 280 meters per second, pull back on your stick, and the aircraft will take off from the runway. Raise your landing gear with the G key, and we're going to climb at about a 20 to 25 degree climb angle. You'll notice at 25 degrees of a climb, we're actually climbing at 38 meters per second. We're going 420 meters per second, pretty steadily, and our altitude is climbing very steadily. I'm going to level off just a little bit. The higher you go, the thinner the air is, and the less speed your aircraft will be able to maintain. So by leveling off, I'm maintaining my speed. You'll notice that the radar altitude indication has disappeared. And you'll notice that as the plane banks left and right, the horizon line on the HUD stays horizontal, while the virtual aircraft banks with what your actual aircraft is doing. So here I am in a 30-degree left-hand bank. Here I am in a 60-degree right-hand bank. You'll notice that at 30 degrees the aircraft turns significantly slower than at 60 degrees. We're going to go ahead and climb to about 3,000 meters and level off there. You'll also notice that now I'm only pointed up at 11 degrees and I'm climbing at 33 meters per second, and that has to do with the fact that my speed is now passing 700 meters per second, and what I want to do is actually drop that down. Going to lower my speed to about 75% RPM. Try and maintain a cruise speed of about 550. Anywhere between 500 and 600 is a decent cruise speed to maintain. Obviously, the slower your engine RPM, the better your gas conservation will be. So you'll notice that my plane's attitude, the angle is 4 degrees up, and I'm actually descending just very slightly, and now I'm level at 5 degrees. And that will change based on your speed and other conditions. Now you're going to notice while you're flying that as you speed up, the aircraft's nose is going to tend to try and rise, and as you slow down, the aircraft's nose is going to tend to drop. All of these effects are due to changes in several forces, including lift, drag, gravity, and momentum, and they're all acting on the aircraft while you're in flight. Again, I'm going to leave it to you to go find some lessons on the principles of flight that explores these concepts in much more detail than what I'm going to get into in here. For the time being, I'm simply going to show you how to adjust the aircraft's flight surfaces to account for these variations. It's also called trimming the aircraft. Trimming a plane is one of those things that always ends up seeming harder than it actually is. It's really pretty easy, but it's something you constantly have to monitor and adjust. It's not something that you just set and then never touch again. Every time you change any aspect of a plane's flight characteristics, you're going to want to change the trim to maintain level flight, or a bank, or a turn, or a descent. I mean, you can trim the aircraft for any variation of circumstances. I'm going to show you how to do that right now. So right now, in order to maintain level flight, I'm going just slightly slower than 500 meters per second. I'm actually going to speed up my RPM a little bit. I'm pulling back slightly on my stick to try and maintain level flight. So what I'm actually going to do is I'm going to use my trim and nose up button a couple of times. And what will happen is as I push trim nose up, I can slowly start releasing pressure on the back, pulling back on the stick. I can return the stick to center. And what the trim does is the trim is actually adjusting the controls that hold the ailerons or elevators in a slightly pulled back position. So go ahead and give it a try. Try and hold your plane at a 0 degree or a 0 meter per second climb. And then based on whatever your input you're giving the joystick, if you're pushing the nose down or pulling the nose back, trim it in that direction just a couple of times until you no longer need to put any pressure on the stick, and the plane will maintain its level flight. So right now I'm actually not putting any input on my joystick, and the plane is maintaining a very slight climb, which is good enough for me. I don't have to mess with it at all. Trimming should always be done in this fashion. Move the stick first to whatever position you want to maintain, and then you want to add trim input until you no longer need to push in on your stick anymore. You can trim the aircraft to fly level, climb, descend, and even hold turns at specific bank angles. The aircraft will stay trimmed in that position so long as it maintains the same forward momentum, forward speed. You could say you've trimmed the aircraft for straight and level flight at your current speed. This means that if you increase your throttle, the aircraft will begin to climb at that airspeed, and if you decrease your throttle, the aircraft will start descending at that airspeed. The aircraft will always try to maintain equilibrium at that speed that you're trimmed for. So right now, 540 meters per second. If I give myself throttle up to 90% RPM, the airplane will actually start climbing. It'll speed up first, then the aircraft will climb. As the aircraft gets to a climb angle where it can no longer maintain that speed, the speed will drop. It'll actually drop a little bit below 540 meters per second. And then once it starts speeding up again, it'll seesaw back and forth until it starts climbing at 540 meters per second. You can help this along, if you'd like, by giving it input on your joystick. Or you can just let it do its thing. So right now I'm increasing my engine RPM to 90%. You'll notice that my climb rate has started going up, 5, 6, 7, 8. And you'll notice my speed went up to 560 meters per second. And as I reach an angle here, you'll notice that my speed just dropped to 550. Now it dropped to 540. It'll probably get to about 520 before it starts climbing again. But what will eventually end up happening is the plane will still be flying at 540 meters per second. It'll just be climbing at whatever rate that is. And I'm not inputting, I just gave it a little bit of a turn input to make sure that I maintain level flight, but I'm not pulling back on the stick or pushing forward on the stick at all. This is one of the cool things about trim. Now if I decreased my speed back to about 80% RPM and then held level flight, the plane would eventually return back to about 540 meters per second. And the same goes for the opposite. If I were to decrease my speed or my RPMs to about 60%, the plane would slow down and then nose down until it reached about 540 meters per second. It would nose down, nose up until it hit about an equilibrium of 540 meters per second. So let's go ahead and level ourselves out. I'm going to drop my speed or RPMs back down to about 80. I'm going to go ahead and manually level myself out here as I fly through a cloud. And I'm not trimming my aircraft right now because I know that eventually it will be trimmed for this speed. I'm just kind of helping it out a little bit. Now let's start learning about turns. Turns are actually pretty easy once you understand the concept. To turn the aircraft, move your joystick to the right or the left until the plane banks in the direction you want to go. Simple, right? Well, not so fast. Let's bank our plane 30 degrees to the left. Remember the semicircle of tick marks on the bottom represents the bank angles. 30 degrees is going to be the fourth tick mark down from level flight on the left-hand side. We're going to bank until our virtual aircraft's wings are pointed at the 30-degree one. Now, I'm trimmed for level flight, but notice that when I turn, the aircraft starts descending. I'm dropping at about 15 meters per second at a 30-degree bank, 16. Now, why do you think that is? This gets back to the principles of flight that I told you you're going to need to go and look up after the lesson. But basically, when you enter turn, you decrease the total amount of lift keeping the aircraft up, so the aircraft starts to drop. If you want to get into more detail, you're actually splitting the lift between keeping the aircraft in the air and turning the aircraft to the left. So you would say that like 3/4 of the lift, the total lift, is keeping the aircraft up, and 1/4 of the total lift is rolling the aircraft, pushing the aircraft to the left. So you'll notice that as I speed up in my turn, my descent rate slows down. It gets closer to level. This is also related to trim. As you speed up, the aircraft is going to want to stay in the air, and as you slow down, the aircraft is going to want to fall. But you don't generally want to just kind of hope that that keeps you in the air. What you want to do is try and maintain a level turn. So what you're going to do is actually pull back on the stick just slightly to maintain level flight. And level flight will be when your climb rate is at 0. So here I am at a 30-degree left-hand turn with a 0, well, -1, 0 climb rate. And that would be a perfectly executed turn. It's not always going to happen, but you should definitely practice it, get into the habit of it. You'll find yourself flying randomly into the ground less. When you're finished turning, move the stick to the right until your aircraft is pointed at 0-degree bank, and resume level flight. You might need to retrim your aircraft after this. It just depends on how much speed you lost during your turn. Might also depend on whether you gave yourself more or less throttle during your turn. Congratulations, you've learned the basics of takeoff and aircraft flight. For now, take some time to fly around a bit, get used to maneuvering, trimming the aircraft at various speeds. Most turns should be made at between 30 and 60 degrees. And don't pull back on the stick too hard, or you could stall the aircraft and lose control. In fact, before we end the lesson, let me quickly touch on stalling. This will be covered in more in depth, whatever extra material you find, and learn about the principles of flight. Stalling is simply the aircraft losing the lift to the point where it can no longer keep itself in the air. This can happen by not having enough forward momentum, speed. It can happen from trying to climb too steeply. It can even happen from trying to turn too sharply. Luckily, we have a neat gauge that shows us when we're doing something that puts us at risk for entering a stall. This gauge is right here. It's your angle of attack gauge. It's the numbers on the left-hand side of the gauge. You'll notice that when I pull back on my stick, the gauge moves up. And when I push forward, the gauge moves down. Negative angle of attack. You'll notice the right-hand side also moves up and down, and the right-hand side is your G load, the number of Gs that you're putting on your pilot. But that's not as important as your angle of attack when it comes to stalling. So you'll notice that at the top of the angle of attack meter, there's a bunch of red towards the top quarter of the gauge, and those, as you've probably guessed, indicate where the aircraft will most likely stall. There's even a little indicator. I believe it's that one, but I'm not sure. It could be the red one up there. And it'll actually turn on just before you stall, and it'll say AOA limit, which means that you're at the limit of your turn, or your angle of attack is pretty steep. You're about to lose your lift. So let me go ahead and demonstrate that by pulling back very sharply. So you'll notice that there's a lot of stuff that happens to warn you that you're about to stall. The angle of attack limit lamp turned on. It was the one to the left of the angle of attack dial. We got a beep, a warning siren. The quickest way to recover from a stall is to give yourself full throttle and try and coax the aircraft to pointing down towards the ground. The aircraft will generally automatically do this. If you give yourself full speed, it'll naturally kind of want to point its nose down. And the thing to do is not to fight that. That is the most natural way to recover from a stall. It's the quickest way to give yourself forward momentum, forward airspeed again. And then that in turn gives you more lift. It's usually better to avoid stalling in the first place, and as you've probably guessed, stalling at low altitudes is much more dangerous than stalling at higher altitudes. So if you want to practice stalls, make sure that you give yourself a good amount of space between you and the ground before you start doing stuff like that. One of the easiest ways to practice a stall is to just cut your throttle, pull back sharply, and you can just wait for your airspeed to drop. Or you can just pull back until the aircraft's nose starts dropping.
Minimum speed.
You'll notice that the aircraft is naturally pointing towards the ground. It's very hard to enter a stall that you can't recover from unless you try and fight what the plane is naturally trying to do. The extra material you need to go and find and read with regards to the principles of flight will likely give you additional options for stall recovery and a lot more information on what causes stalls and how to know that they're coming and avoid them. If you wish to practice with stalls, make sure you have plenty of altitude before going crazy. And that concludes this lesson. For more information with regards to the various gauges on the front console that we've covered in parts 1 and 2, take a look at pages 8 to 15 in the SU-25T manual, which is included with DCS World. I also strongly recommend you take a look at the extra material that I've been telling you about this entire time, relating to the principles of flight and flight mechanics. In our next lesson, we'll cover the various navigation and autopilot modes the SU-25T provides. Thanks for watching.